Hey guys, my name is David Szabo. I work for Virgil Security. And today I'm going to walk you through Apple's end-to-end security. I want to make sure that it comes across how complex and sophisticated it is. And I also want to show you techniques of how you can build that end-to-end encrypted technology and security into your apps beyond Apple. What entitles me to talk about security? We are the tech behind Twilio's end-to-end encrypted chat. Many healthcare apps are using our tech to end-to-end encrypt their patient data, their health records, or end-to-end encrypt their healthcare chats. Most of our open source users are in the healthcare market building healthcare apps, either chat or records management or health records management. But we also have a bunch of users who are using our tech for building closed social network apps, dating apps, all sorts of stuff where you want to encrypt and protect your profile data or photos with cryptography. So end-to-end encryption is this thing that everybody knows by now, and it looks like it's going to stick around for a while. There's no better invention for now than end-to-end encryption for really protecting your app data. And that little icon in the left, WhatsApp, was sold for $19 billion to Facebook not too long ago. It's a strong value proposition to be end-to-end encrypted. It's something that, in my experience, users by now are looking for, because you guys are using encrypted chat. I'm using encrypted chat. When you are downloading an app and there's a chat component in it, you would ask the app developer or try through the app description if it's end-to-end encrypted or not. So it's out in the air. It's a requirement for many users. So if you look across all these chat apps, they're all end-to-end encrypted. And I'm pretty sure that there's 20 or 30 more that I haven't listed there that are end-to-end encrypted. And that's where the world is going. One of our open source users is this funky app, which is the Capitol Hill and White House version of WhatsApp. It's a geo-fenced version of WhatsApp that politicians use in the White House and Capitol Hill to message with each other end-to-end encrypted. So they can keep their opinion within closed boundaries and through using cryptography protected. And there are many other apps getting there to implement end-to-end encryption. So it's not primarily for chat apps anymore, but there are many healthcare apps where developers have struggled to implement HIPAA compliancy. For example, developers want to protect patient data and privacy, but they don't really have the right tools, and they also need to be HIPAA compliant. So they end up implementing a solution that we implemented with Twilio, that data never gets into the backend system decrypted. It is encrypted on the client devices with a key that never leaves the client device. So your backend won't see patient data. But today I want to talk more about Apple. And you guys, I presume most of you are Apple users. So we know that Apple always has this marketing slogan that we built our devices with security in its core. And it's not just a marketing slogan. If you look through a couple of examples that I put together today, this is the little pop-up that pops up when you add a new device into your iCloud account. You have a new iPad, you say I'm adding a new device, you log in with your Apple ID, and this is the little pop-up that you get on the device, and there is another pop-up on another device of yours that says, hey, type in this number, and then your new device can be onboarded. So many of you would think that this is just a two-factor authentication verification, but technically it is to identify the two devices, and followed by which there's a very complex end-to-end encrypted key exchange happening between your old and new device, where your old device takes your keychain and encrypts it with the new device's public key. So it's end-to-end encrypted device management. Apple doesn't have access to your device data. Apple doesn't have access to your keys, even though they transfer all your passwords and keys and everything that you store in your keychain. Apple won't be able to decrypt it. It's beautiful, it's perfect. That's how it should be. And then yesterday in the keynote, we heard about memojis, which makes iMessage even cooler. But what really makes iMessage cool from a cryptography perspective is it's end-to-end encrypted. It's like WhatsApp. that $19 billion feature is built into our iPhones by default, and that's how we chat. It's end-to-end encrypted between all the users that we are chatting with on iPhone, on iMessage. Each users have private and public keys, and then there is thread keys that are shared and encrypted between the users. It's zero knowledge end-to-end encrypted messaging, which is a really cool feature if you look at a basic default messaging feature in an iPhone, in an app. And then this invention that they call Keychain that lives on your device. It's all your secrets, all your passwords, all your device keys, everything that somebody would need to be you in your iCloud account that is encrypted with a bunch of stuff like your Apple ID password, your PIN number on the device, and what's even more important, with your Face ID or with your Touch ID. So Apple built this little button into the iPhone that when you touch, it derives a complex cryptographic key from your biometrics. And that key is used to encrypt your keychain. How awesome is that? If you think about it, how much innovation goes into this basic feature that you push a button and you don't have to type in a PIN number. It's really strongly built cryptography. There is no doubt why it's Apple that made the headlines with the FBI and not Google's Android. Hacking a Google Android has never been an issue when you're in a litigation compared to the strength of an Apple device. It's all cryptographically sound, end-to-end encrypted. Try to break an electric curve key. That's go figure the cost. If you look at Apple's site and you just do a search for the security white paper, iOS Apple security is available in the form of white paper. There's an iOS security document, 81 pages long, and as you would expect from Apple, even an 80-year-old would understand at least half of it. So it's a really good read for you guys to really understand the complexity and all the effort that goes into building the iPhone and maintaining it and keeping it secure. And Apple is one of the few companies who made an art out of balancing user experience and security. It's really hard. Most of the beautiful apps are unsecure and most of the secure apps are not beautiful. So Apple is one of the few companies who can find the balance in the middle and actually do both. So your iOS app with iCloud is perfect. It's end-to-end encrypted. That's where you want to be. That's where FBI or, I'm not talking about FBI right now, but let's say if a hacker hacks into catches a device or hacks into a cloud account, that's what a hacker would see if they hack an iCloud account. It's end-to-end encrypted data. And that's how it works. You have two devices, maybe you're chatting with somebody else and data encrypted on the client devices with a key that never leaves the device. So your iCloud in the middle doesn't see anything. That's how your Apple experience works by default. But I doubt that that's the kind of app that you guys are building that has an iPhone and uses the user's iCloud document storage for storing documents. I think you guys are building cooler apps than that, which means that you end up with using maybe a backend service like Firebase or Twilio, and as my emoji says, you end up being in the Wild West. Because as soon as your data gets out of this beautifully encrypted Apple enclave, it goes into Firebase or it goes into Google Cloud or AWS, where every single front-end server, every single database will see your user data. And you're hoping, maybe praying, that Google or Amazon does a good enough job to protect your data with this data center security or network security and all the stuff that are not visible to us. And then, of course, you guys would have other platforms, not just iPhone. You would have Android, and eventually you would have a browser app. So you would end up with the lowest common denominator, which is probably the browser app, and your beautifully designed Apple end-to-end security is over. You have a couple of cloud accounts like Firebase and Twilio, where every single data is accessible to your provider, hopefully not to hackers. also available to governments or anybody else who really wants to peek into that data with the right technology. And then you have devices that are less secure than your Apple end-to-end security. So you will end up with a regular app that is using HTTPS and at-rest encryption, and something like that. So when you have two devices and all the data is coming through and is visible in the middle, not like that. The one that you don't see from the animation, which is not happening. So the question really, going back here, how can you take this real world use case of having multi-platforms and a cloud and still build the end-to-end security that you experience and your end users experience on your Apple device? That is the million-dollar question. And that's what our open source SDKs help you guys do that. This is one example that we are actually I am actually announcing today. We are integrating with Firebase, as the t-shirt says. So if you guys use Firebase as a backend for your iOS or Android app, you can download our open source libraries, and you can download a chat sample app for both platforms, and we'll have a JavaScript version as well that implements end-to-end encrypted chat in Firebase. So if you have if you zoom your eye into the middle, into that rectangle in the middle, that's what Firebase and Google sees when your users are chatting. So the messages are encrypted with keys that we keep on the client devices. And then what goes into your backend, what goes into your Firestore or into your Twilio or into your AWS cloud is encrypted without the encryption key. That was the FBI, sort of the FBI challenge, but this is on the backend. So in the next few minutes, I'm going to walk you through what are the steps that you developers in the front end in building apps can do to enable this end-to-end encryption in your apps. So step number one is create keys for your users. Every time when you sign up a new user or when an existing user logs in that you haven't created keys for, make sure that every single one of your users have a private and a public key. If you know anything about crypto, the way private public keys work, you give out your public key to all the other users so they can encrypt data with it for you, and your private key decrypts the data that they encrypted. So that's 2 lines of code with our open source SDK to really generate a key for your user at sign up, keep that private key on the device, and then the next line of code is to publish the public key to our cloud, where we have a user directory where users can look up each other's public keys by their username or user ID. So with this step, you end up with an app where now users, where it's established to implement end-to-end encryption, because every single user has a private key and public key. You can encrypt data from Alice to Dracula by downloading Dracula's public key and then encrypting a piece of message to Dracula and sending over the encrypted message through your backend. It's really simple. So that's step number one. Remember, create keys. Make sure that every user in your system has keys. Step number two is whenever you have any sensitive data in your app, like a chat message or that guy taking a selfie, make sure that you encrypt that data. And the simplest form is, if you already know who should have access to that data because you have ACLs in your app, then you should already encrypt that data with each of those user public keys that you know who will want to access that piece of data. So if Grump is taking a selfie that wants Alice to see, he will encrypt the selfie after it's taken, the moment after it's taken, by using Alice's public key and his own public key so he can see it. And if he adds more friends to his photo library, he can encrypt it with other users' keys. This is the simplest approach. And then that photo will be stored in Firebase or in your backend database, completely end-to-end encrypted, without your cloud service provider ever be able to decrypt it. So these are the 2 basic steps. And then the third thing is a guidance that most people start losing device. Well, if I remember back like the last 2 years, I think I replaced my device at least 3 times, if not 4, and on one occasion I lost it. So that means if I go back here, you know, my private keys that decrypt all the photos from Grump to me is lost. So I cannot decrypt it anymore. So the third step is make sure that those user keys, those user private keys are safe. And this is where most apps go crazy, where they start to back up the private keys and write it into a database, and then you end up with a database that has private keys, so it's a mess. We built a technology called BrainKey, which is very similar to Apple's Touch ID, that we are using an algorithm, that elliptic curve algorithm that is used by the Zcash cryptocurrency to derive a very complex cryptographic key from the user's password. So our BrainKey technology enables you guys not to store the private keys on the device and then lose the private key when the device is lost, but regenerate those private keys every single time the user logs in from the user's password. And it's a strong private key that matches with the public key that's been already published in a cloud. It's a really cool new approach. Nobody implemented this before. We have actually released it earlier this week to avoid storing and having private keys on the device, but rather have a key that we derive from a password. Question?
Don't you then lose that if they change their password?
So if the user changes a password, then all you have to do is regenerate the key. So create a new key and then replace the public key with a new one. You need to validate or verify the user if she is who she says she is, and then you can redo that operation.
All the data that you've already.
Yeah. So the way you would, and this is something I'll invite you guys to a workshop tomorrow, same time, 10 a.m., where I'll talk you through like end-to-end encrypt and key management techniques. But long story short, the way you would build your app is you have a user private key that is encrypted with the user's brain key. And if there's a new password, then you just re-encrypt the same private key with the new password key, and this same private key still decrypts all the data. So as soon as you start figuring out these building blocks, you can build like crypto Lego with real simple couple of lines of code, and that's why developers love our open source SDKs like Arduino or Raspberry Pi or Legos, building cryptography with really a few lines of code across all client platforms, JavaScript, iOS, Android, everything, Swift, Objective-C, all client-side tech. So you can encrypt keys as well, not just data. And then you encrypt the keys for the users who should have access to that key, and that key decrypts all the data. So come over to our workshop tomorrow at 10 a.m. And we'll have a 2-hour workshop where I'll walk you guys through end-to-end encrypted key management techniques. So I already announced, but doing it one more time, we are integrating with Firebase. How many of you guys are using Firebase today? Cool. So you can jump on it straight away. If you go to that URL, virgilsecurity.com E2EE chat, end-to-end encrypted chat, sign up, and you can already have a look at our Firebase sample for iOS and Android, which is the simple chat app that I just showed you. It's real simple, and it has everything that I explained today. You can set it, get it up and running with your Firebase account in 10 minutes. We need to deploy a function in your Firebase app which enables you to use our tech, and then you're all set. And Android and iOS apps are ready to reuse chat apps. So tomorrow's workshop at 10 a.m. at AltConf, I'm going to cover 2 things. One is go and do a deep dive of end-to-end encryption, how you guys generate keys and use end-to-end encryption in your app, how you do all the end-to-end encrypted key management, and I hope that you'll be walking away with seeing how simple it is. It's really building Legos, and I hope that all the basic principles of cryptography will come through. Our approach is really not to teach crypto to developers, but rather give you guys reusable like SDKs that make it super simple. And the second topic that I'll cover tomorrow briefly is I'll show you guys an alternative technique for password hashing. How many of you guys are using password authentication and hashing your passwords today? Yeah. So those password databases are all prone to breach because you need to use store the salt and the hash password, and it's only a matter of a rainbow table or a brute force attack that really decrypts, reverse engineers all those passwords. So there are folks who are switching over from mining cryptocurrency into breaking passwords. They got $3 to $10 per password. So I'll show you a technique tomorrow. It's a new product that we are shipping, also open source, of how you can move away from that and how you can use a remote salt in your salting and hashing that really prohibits anybody taking your password database and reverse engineering it. So come over if you want to secure your passwords tomorrow, or come over if you want to learn about end-to-end encryption. And that's it for now. I'll take any questions. I think we have enough time to take questions.